Hi guys, welcome to another quick video on HTZ RESTful API. So we'll be launching a couple of videos on the capabilities of RESTful API, the extended capabilities of HTZ Warfare that the RESTful API provides, like configurable workflows, automated workflows, and really being able to mimic and simulate real-time battlefield situations. So there's a couple of things that we've discussed, different scenarios like on-the-move jamming, moving managed networks, and how an ongoing link analysis. For today's video, we actually have a very interesting use case. It's something that's very prevalent to today's battlefield environment, which is electronic warfare capabilities, particularly counter UAV system design, and the performance of these counter UAV networks in real time as well. So what you see on the screen in front of you is a counter UAV network around, and obviously it's a specific setup around the Changi Airport in Singapore. Now, one of the main components of a counter UAV network, you've got a bunch of direction finders, you've got some radars, and you've got some jammers as well. So the direction finders and the radars are there for detecting specific drones as they're flying into the area, and the jammers are for obviously taking specific countermeasures. Now you'll notice a white polygon there as well. So the white polygon is just to identify a region of interest from which point, like as soon as a drone enters this area of interest, we are interested in the detection of that drone as well as the specific countermeasure, how we're going to deal with that drone. Outside the white polygon, right now, I'm not concerned. Again, so that's the basic counter UAV network. Again, this is HTZ Warfare, and this is utilized by various armed forces around the world. It's able to perform all types of RF simulations for courses. And obviously, this is the kind of capability that we're going to be showing. So I've got my Web API, our Web API engineer, Chris, who's going to take you through the specific workflows. Chris, whenever you're ready to get started.
Okay, so thank you, Edna. So as you can see, this is the counter UAV sort of scenario project. So we have those UAV one coming from the bottom to top, as you can see, and we're showing the UAV two is coming from top to the bottom. Okay. So let's go straight to API. Okay, so this is one of our GUI, just to show you the proof of concept of this counter UAV scenarios. So I loaded the project. So as you can see, this is the Singapore area. So let's go straight to counter UAV analysis. Okay, so I'm going to start with getting the station on the map. Okay, so as you can see, we have 4 DFs and 2 radars and also 2 jammers. Okay. So let's
just slow down a little bit, Chris. Can you go to the station list? Just to show them. Yep. Slow.
Yep.
Yep. So okay, so this is automatically loaded right from the HTC backend. So we're loading the station list into the GUI. Okay.
That's right. All right. So first of all, we are going to load the CSV. Containing this UAV path details. So I'm going to load UAV path 1 here. And you can see the details of waypoints at this UAV path 1, including longitude and latitude with the height. Now I'm going to import UAV path 2.
While you're doing this, Chris, just add one thing. So this is, we're modeling the entire flight path of these UAVs. Right? So you can model as many UAVs as you need to model.
That's right.
You can see that the XY coordinates and also the XYZ, so the height information can also be fed into the platform. You can do CSV imports, or they can be imported using RESTful API as well. So you're getting that real-time moving drone, right? Simulation.
That's right. All right. So for now, we're going to use 2 UAV paths. So let's confirm this UAV path, and we can also double check which DF is available on the map, which radars are available on the map, and which jammers are all available on the map. Okay, let's start with displaying the coverage output for DF and radar and jammers. So for DF, let's say DF coverage. For radar coverage, let's say minimum target height is 100 meters with the maximum target height of 200 meters. The coverage depth of 5. And our target RCS, let's say 5 square meters. Run radar coverage. All right, and then for jammer coverage, let's say our target height is 100 meters. And jamming frequency 350 megahertz. And run jammer coverage. And this is the jamming efficiency part. So we are going to use this J/N criteria. So if the J/N is greater than or equal to this 50 dB, then we are saying the UAVs is successfully jammed by the jammer. Okay. So this coverage output will be located at here. So it's currently running the queue. So as you can see, whenever you call an API function, those are queues. Okay, so you will serve the first queue and the next queue and so on. Okay, so I think we've got the DF coverage ready. Let me display the DF coverage. Right. So this is the DF coverage. As you can see, we have ODF and DF coverage. And you can also notice that there is a bit of a power drop. It's because of there are lots of tall obstacles, tall buildings. Okay.
Just a quick question, Chris. So this coverage calculation should run before the drones even enter the area, right?
Yeah.
Okay, so we've already run the coverage calculations and then we're going to simulate the flight path.
That's right.
Okay, all right.
So this is just to visualize the coverage output.
And this is part of the system design, right? You obviously need to know the coverage of your sensors and radars before, obviously, you're interested in your real-time simulation. If it's going to be able to cover the region of interest, right, sufficiently. Yeah. That's kind of what Chris was showing.
That's the point. So this is one of the radar's coverage, the radar 2. As you can see, the radar coverage, the legend is the minimum target height. Okay. So, right, this is the radar 2. So as you can see, according to the pilot, this green is 100 meters. So the UAVs has to be 100 meters or greater than or equal to 100 meters, the height, to be detected by this radar. Okay, if it's in the red area, it has to be greater than or equal to 160-meter height.
Anything lower is not going to be seen, right?
Yeah, that's right. And you can see there's no coverage here as well because it's all obstructed by those buildings, tall buildings. Okay. And then right. And then now the JAMA coverage is coming. Okay. Okay, so this is the JAMA coverage. Okay, so as you can see, there are 2 jammers as well here, and with the DSN radars on place. Okay, so let's now dive into the counter UAV analysis part. All right, so we are going to run the analysis. So let's run analysis. Okay, now in time equal to 2, there is 1 waypoint detected. All right, detected by the DF. So that's why it's colored in yellow here. Now it's radar detection in progress. It turned green because it's detected by the radar. And after that, it's gonna look at the jamming analysis. Now it's in progress. If it's jammed, it will turn blue. Okay. So this at time equal to 2, the analysis is completed. And you can actually see the details of analysis here. so this is UAV 1 waypoint 3. So it's got full overlaps of DF coverage. So it's detected by the DF with the accuracy of 90 meter. And this is the radar point-to-point calculation analysis. So it's detected by the radar 1 only. And for the jammers, so you can see the J over N value from jammer 1 is 63.9, which is greater than our predefined J over N criteria, 50 dB. That's why it's jammed by J1.
And jammer 2 is not
Jammer
able to
2,
jam because
because
it's not
lower
the
than
criteria. So this is essentially distorted our flight path drone movement, right?
Yeah.
And this is the first waypoint.
Yeah.
This is the analysis at this point in time.
That's right. So now let's look at the next time interval. So now it's t equal to 3. All right, you can see those 2 waypoints. It's within polygon area.
So that drone just essentially moved to the next waypoint.
Yeah.
And we see the appearance of another drone from the top.
Because it's now within the polygon area. Those 2 are detected by the DF, that's why it's yellow. But one of them turns green because one of them is detected by radar. Now the jamming analysis in progress. And if they are jammed, okay, so both of them are jammed, okay, because they turn blue. So we can also see the details here, the overall number of overlaps of DF coverage, and then whether it's detected by radar or not, with the field strength received values, and also the J over N values with the jamming status. Okay. And we can run the next analysis again for t equals to 4 now. Okay. So now we move to here, this UAV moved to here. So this is detected by the DF, this one as well. Okay. So now it's in radar detection in progress. So if it's detected by the radar, it will turn green. So only one of them here is detected by radar, so it's turning green. So now jamming analysis in progress. So it will turn blue if they both are jammed. So only one of them is jammed here, okay, that's what it's colored in blue. And again, you can see those detailed information about those waypoints. Okay. And from here, we can just run this next analysis automatically until the end of the waypoints. And let's run it. So now it's 5.
Guys, while we're running the analysis of all the waypoints, essentially from the start of the flight from the start of the flight to the end of the flight, which is the last waypoint, I did want to say that this is a specific, very nuanced design in terms of the color changes. Again, it's completely customizable. You might only care about DF or sensor detection, or you might only care about radar detection. So this can be completely customized based on how you want to visualize this workflow.
That's right. And because basically we are customizing this style based on this detailed information of the waypoints, like number of overlaps, and also whether it's detected by radar or not.
And that's an important figure, isn't it? The number of overlaps, because you could have DF coverage for from one direction finder, but if there's no overlapping bearings, there's no intersecting bearings.
That's right.
It's not going to be detected. Okay, so it's good to know.
All right. So as you can see, it's working on the waypoint 7, which would be the t equal to 6. Now it's moving to t equal to 7, which is so t equal to 7. There are waypoint 8. Okay. So DF detection in progress. Both are detected by DF. And radar detection in progress.
So it's running point-to-point calculations at the moment. So it's quite snappy for point-to-point calculation, but there are various workflows that can be constructed to make this faster. And yes, definitely we can discuss that later.
Okay, so completed. So this is the whole detailed information of the waypoints, of the overlaps of DF, radars, and jammers. Okay. So you can also analyze a specific time interval at this point. Okay, so let me just explain this table first. So at t equal to 0, those are the waypoints of the UAVs, and they are both outside of the area of interest, so we don't care about those analysis. And t equal to 1, also both of them are outside, so we don't care about it. At t equals 2, only one of the waypoint is inside of our AOI. So we do the analysis. It's detected by DF, detected by radar, and also jammed by jammer 1. And t equal to 3, and t equal to 4, and so on. Okay, so you can basically analyze at each time interval. So let's say, right, I'm interested to have a look at t equal to 4. Then let's just choose the time window as t equal to 4. Then those are the waypoints at t equal to 4. So waypoint 5, okay? So those are the locations of the waypoints with the height information. So let's say I want to analyze that t equal to 4. Let's click it. Then it will generate the jammer coverage at t equal to 4 with the UAVs placed on the map. Okay. As you can see, it's in the queue at the moment. So let's have a look at this jammer coverage. So again, this is the jammer coverage when t equal to 4. And as you can see, there are two UAV waypoints, the UAV 1 waypoint 5 and UAV 2 waypoint 5. Okay. And you might have noticed that there is a big power drop here, the jammer power drop. So it's because of the tall buildings, the high obstacles. So this looks like it's not like J1. So we can actually validate it from this table. T equal to 4 at UAV 1 waypoint 5 by J1. It's not jammed by J1. Okay. So you're validating.
So the jammer coverage doesn't even extend to that point.
That's right.
I see. That's why. Okay.
Yeah.
That's the reason why
Yeah.
it's not detected.
Yeah. And as you can see, this UAV 2 waypoint 5, it doesn't look like there's not much of obstacles. You can see there's no power drop. So it should be jammed by J2. We can validate it using by looking at this table. This UAV 2 waypoint 5 is jammed by J2. Okay. So this is the specific time interval analysis you can do. All right. So this is the counter UAV scenario that we designed, and quickly I want to show you guys another GUI example that you can actually make it from the scratch with the developers. Okay. So if you're designing from the scratch, the time response to latency will be really good, so fast. Let me just quickly show you.
Yeah. So obviously there was some
limitation.
Yeah, in terms of the speed, right? Even though it was running point-to-point calculations, but obviously we were using a packager like retail. But this is obviously what a proper application would look like.
That's right. Right. So let me start. So it's false. HTZ is running. Okay, I'm going to maybe let's run this, load this project, test it. All right, this is our project area, station. All right, let's get the station list. All right, this is our station list. Here in this example, there is a Wi-Fi 4. You can see some details here as well. Okay. And also, if you're interested in like coverage calculation, you can do so. Run coverage. Let's say, okay, I want to run all of the coverage with the 1 meter RF antenna height with the maybe 1 kilometer distance for a quick output. Say no output. Let's run, and you can actually check whether it's possibly queued. So it's finished already. So if I display the composite coverage map, you can see it displays the composite coverage map of the coverage, the 1 kilometer coverage of each Wi-Fi.
So it definitely feels faster.
Yeah, a lot faster.
So again, this is obviously not the same scenario, right? I just wanted to show you that for proper GUI, once designed, can really, really amplify the workflows of HTZ warfare. And yeah, I mean, obviously today we're talking about a counter UAV example. Obviously simulating the flight paths of these drones and analyzing detection, analyzing probability, success of the jamming. But yeah, this is just a quick video on some capability of the RESTful API. So,
All right, thank you guys.